All right, hi everyone. I am going to be streaming a bug fix because I was going to fix the bug anyway, and I've got an uninterrupted chunk of time, and let's just see how bad it is going to be to fix this bug. So this is the bug. It's factory functions unable to accept FakeTensor as input. This one's going to be related to, I think, the Python argument parsing in PyTorch. So the problem is essentially if I call torch.zeros and I pass it a fake tensor as its argument, this doesn't work. And specifically, what they want to do is if I have a tensor that is representing a bunch of numeric elements, we have this behavior in PyTorch, which is that we will actually cast it into a list of integers and then process it as if it was that. So this is going to be equivalent to calling zeros with the size 3. So we're going to get a size 3 1D tensor out in this case. So what do we need to have happen when we do this with a fake tensor? Well, we can't actually do this with only fake tensor. Actually, I'm not even sure what this is intended to be. Okay, let's write this down. So it's not altogether clear what the intended semantics of this program are with a fake tensor. In the case that works, we know the actual value inside tensor. And so we can produce a tensor of size 3. But if I have a fake tensor, I don't actually know what the value inside the tensor is. So how can I generate a output tensor of some unknown size? That being said, there is a case to be made that this should work under makeFX symbolic tracing, where the intended semantic is you get a I0 size tensor, where I0 is an unbacked cement. I want to just check this internal post for a second. Sorry, stream's not allowed to see this, but there was a real user reported bug, and I just want to check if this is the actual thing. Okay, interesting. Are they using Dynamo? They're either using Dynamo or they're using makeFX. Well, I guess we'll have to write some test cases to see. I can't tell if they're using Dynamo or makeFX, but I know makeFX doesn't work, and let's go ahead and try to make makeFX work. All right, so you all cannot see the screen. Here we go. Huh, I'm cropped vertically. Why am I cropped vertically? There we go. Much more roomy. Okay. All right, so what do we want to look at first? So what we want to look at first is we want to look at making a reproduction. So let's just make a little repro script, and What do you want to do? Let's do make effects. Let's pass it a tensor. That's going to be our size. I don't remember what this returns. Whatever. And what are we going to do? We're going to pass this as directly as an argument here. And that's an integer. Looks good. Let's give it, is it tracing mode? It is tracing mode. I think it comes out as like graph or something. Let's see what this does. Can y'all see everything? Y'all can see everything. Okay. Not symbolic shapes, it's in proxy tensor. All right, so 0 is expected size to be a tuple of ints, but found element of type FakeTensor. Looks pretty reasonable. And, you know, let's just make sure this thing works if you call it with a real tensor, which I'm pretty sure it does. Yeah, see, works with a real tensor. Okay, so here's our bug. Okay, oops, I did not want to do that. Okay, how are we going to fix this? So the problem is with argument parsing, as I suspected. And what it is doing is it is saying, okay, I'm trying to parse the argument for zeros, and somehow there's some logic which is special casing the tensor case, but it's not working when we get a fake tensor. So let's go ahead and look at this code. So we're going to find this code. Well, unfortunately, we can't actually grep for it in the source code because zeros is a constructor, and constructors in PyTorch are all automatically generated. And here's where having worked on PyTorch for 5+ years helps. I know exactly where the code for this is. It's in generated code. It's going to be Python torch functions. And I don't remember which number it is in, so we're just going to look for it here. And I'm just going to look for zeros. I guess it's THC variable zeros. Okay, here we go. And what does this say? It says, hey, when you are calling zeros, we're going to try to parse an int array ref, and we're going to try to parse a sim-int array ref. And I mean, seems fine. And so we're not going to, I don't know which overload we're getting. That's weird. I wasn't expecting there to be 2 overloads. We're going to have one of these overloads. So either going to be int array ref or sim-int array ref. So what's the string format? So this string format is a little mini DSL in PyTorch we have for doing argument parsing. And the argument parsing in this case is going to be done in Torch CSRIC utils, Python arg parser. There's like some enum. Yeah, so it's either int list or sim-int list. I happen to know they parse this way, but yeah, here's the mapping. Int list or sim-int list. So I don't know which one it is, so we're just going to look at both of them. Well, you can see these actually go into the same thing. What do I want to look? Yeah, let's look at is int or sim-int list. Okay, so what does this say? So how do I check if something is an int list or a sim-int list? Well, if I get a list, then that's fine. Otherwise, if the list, if we have a broadcast size, but we don't, That's weird. So it seems to me like this always returns false in this case. So we could check this by editing the C++ code and then recompiling, but I don't feel like doing that. I might do that in a case of last resort, but this seems a little blah. You notice there is some logic for handling if you are JIT tracing and then you have a scalar tensor as the argument. It will let you do it in that case. But this is very strange. This is not what I was expecting. Do tensors advertise as PyTuples or PyLists? No, because those are checks from the CPython API, so those are going to be exact. Oh, we might have to put in some debug statements. Ugh. Oh, let's check the logic here. So there's some more logic in the header for actually handling the thing. Is there? There isn't. All right, let's put in some prints because I give up. I don't know. It's very strange. So what we're going to do is we're going to run it in the correct case, and I want to find out what exactly the code path we're going down in this case is. Let's recompile. While we're waiting for that, I just want to stare at this some more. Torch.tensor. Oh, this might be going down the JIT tracing code path. So what am I thinking about here? So I assumed that this was interpreting the torch tensor as a 1D tensor giving all the arguments, but that may not actually be what it's doing. So if it's a 1D tensor and I'm reading out the arguments, then this should work. But I'm actually thinking this isn't going to work. Yeah, this didn't work. Okay, there you go. Must be a int. So why is it printing 0? Oh, position 0. Okay. So what's actually happening is that this is equivalent to this. Let's go ahead and check that in here. That's actually what's going on here. So what we're going to expect is with the debug print, we're not actually going to see, well, it's being called a lot. That's way more times being called than I was expecting. Let's put a print right here. Is cement or list? Is cement or list? Oh, I guess we're checking this for every single argument. But you can see that it's returning 0. So we never say that something is an int or a cement list, and that's what we expected because what we read in the code was it said, hey, you know, this is always going to be this. We're never going to allow tensors unless we're doing JIT tracing. So what's actually happening is we are getting something in here. This is the thing. I think so, because this code works. Yes. So we're going to test if the item is int or cement. So that's the important function. Okay, so let's see. So if it's a cement, or if it's check index, or ooh, what's this? Is Dynamo compiling? Who added this? This looks very suspect. Okay, well, this is probably the bug. I bet if I delete this. Okay, let's just run an experiment. So let's go ahead and recompile this without that condition. No one on the stream yet. Say hi if you're in the chat. I'm looking at the chat, and I'm happy to answer any questions anyone might have. This notification is taunting me. I'm just gonna close this. Okay. Sorry, I need to run the actual failing case to get this. Yeah, you see that? That worked. Okay. So basically the problem is that we are only allowing variables when it is dynamo compiling. So that's kind of weird. So this is enough. I wanna send this in, but we need to explore a little more because I don't think it's correct to put in this patch. Someone put this in at some point, and there was a reason. Okay, so let's use our favorite toolkit pickaxe to find out who added this. Dun-dun-dun, it was me. No. Oh, it was an open source. Okay, someone open source helped us out and sent this in. Let's check this out. Failing mechanism. In dynamo mode, passing a numpy int, shape wrapped in the FakeTensor. Parsec says FakeTensor. Allow submit this one in dynamo mode. Needs test. See, it hasn't failed. I asked Elias to review this. See, I just apparently I've looked at this PR, but I didn't actually look at it. And oh my god. This is the PR that added is dynamo compiling. Oh man. Oh. What the heck? Why did I say yes to this? This is cursed. Is dynamo compiling false? New callback. Oh my god. Oh. And is this the only place we do it? We do it in 2 places now. It was the same thing. It's basically saying, hey, if you get a tensor, then be willing to bong it out. Okay, so let's think. So what this does not explain is why doesn't the logic fail when I do plain eager mode? Because in plain eager mode, I'm not dynamo compiling either, but it's still being willing to do this conversion. Yeah, how come? Why? Is it because of this? Am I casting here? Let's do a printf debug, I guess. I wonder if this will print nicely. I don't remember what Python 11 printing gives me. I need to put back iostream. Oh no, this is the header file. Ah, curses. This is going to take some time to recompile. Wait, did I want to edit that? Maybe I didn't want to edit that. Oh no. Oh yeah, I didn't want to edit that site. I wanted to edit a different site. Curses. Okay, let's hit the right one. I wonder if check index is reporting true. Well, we can just look at tensor to find out. Tensors, I think, are valid indexes. Hi, but fake codes, welcome back. So for those of you who are just joining us, we're fixing this bug in PyTorch, which says that, hey, I can't pass a fake tensor as an argument to torch zeros, which apparently works because when you have a tensor, a scalar tensor, we'll treat it as a size. And I'm like, that's because someone is not allowing us to do this. So how come you can do it for tensor? Question mark, question mark, question mark. I didn't check the index hypothesis, by the way. So let's import torch, make a tensor, and then call index on it. Yeah, that works. So did we disable index on FakeTensor? Possible. No, we didn't disable it. That's weird. All right, well, let's see what happens. Okay, so check index is true a bunch, but I'm not sure what that actually tells me. Lol. Check index is true, and then I had it print the pi handle on the object, and then new end. Why is it printing twice? That's so strange. Am I dreaming? Or are we dancing? Let's try slapping a pi repr on this, maybe? This print doesn't make any sense. Probably messed up. Do I have any prints in the Python script? No, just fr. All this Stone Age printf debugging. The reason I do it this way is because GDB takes a really long time to load, and I don't have a debug build, so trying to solve this stuff without a debug build is kind of cursed. I don't know, man. That's so weird. Why is it giving me this gobbledygook? Okay, so if this is to be believed, the thing I'm printing is tensor 4. Oh, you know what's going on? It's a nested call. So there's a nested call to check index on -1, which is obviously true. And when I check index on tensor 4, it is true. And somehow, when I check index on a fake tensor, that's not true. Well then, we can also test this out. Yeah, see, fake tensor reports that it's not. It's not because it's a guard on a data dependent sim node. Okay. Yes. This makes sense. And I don't know how to solve this, actually. Lol. Okay, so for the benefit of the class, okay. So what's going on here is that there's a special case for the tensor case in Dynamo, probably to handle fake tensor. When done in, but we actually probably solved it the wrong way in that PR. We must consider the question, why does it work? For regular eager mode. Works for that case because we don't need to put, because a scalar tensor implements index. And so the earlier conditional will consider the tensor to be an index. Now, if we try to run index on a fake tensor, we get this is because I0 is because we don't know what the value of the fake tensor is. So we generated a cement, but then we are forced to convert it into an int because that's what index demands, and we can't do it, so we fail. One way we can solve this problem is avoid calling index even in the regular tensor case. All right, let's try to actually call implement this. So I mean, this check actually definitely works. You know what? Yeah, we're going to just do a Stone Age way. Let me just check that this was completely added anew. Is Dynamo compiling? Yeah, these are completely new tests. So all we need to do is get rid of this condition and then hoist this up before the check index call. So in order for this code transformation to be correct, whenever check index, let me think. Whenever this condition is true, then check index must also have been true. But this clearly should have been the case, because if I have a variable and the variable has one element and how strange. let's check some behavior about regular torch tensors. So if I have a floating point tensor and I call index on it, what does it do? Only integer tensors can be converted to index. Okay, savvy. What if I have a 1D tensor? 1D tensors work. And scalars work too. Okay, so not only I want the numL to be 1. Let's just check what happens if I give a 2-element tensor. Yeah. Okay. What if I have a unusual D type? Oh, but we're checking integral type. Okay. Yeah, I think this is good enough. Let's try it. Now let's get rid of that IO stream. Bye bye IO stream. Nice knowing you. So we've hoisted this up and we've said that we want this condition to apply all the time. In eager mode, this is equivalent to what we had before, because check index would always have returned true anytime you have a tensor of this form. And by bypassing check index, we also bypass this problem. So it didn't work. Oh, because I'm printing out index. Ha 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 ha. Let's get rid of that. Let's add some comments too. Yeah, there we go. See? Wonderful. I love it. All right, let's send it in. All right. Cue montage music as I clean up the rest of the PR as necessary. Once again, if you're in the stream, feel free to chat. I love audience interaction. But we can't go with via index below as we would normally do for regular tensors, because index first forces a conversion into an int, which in general you cannot do if you have a unbacked cement. So this fast path ensures that we still allow for tensors, in this case, but for regular tensors, it's redundant with the test below. And then we just need to add a test. These tests typically go in test proxy tensor, and we're going to put it in symbolic because it needs a symbolic. Let's find a random spot to put it. How about here? I like here. I like pie. I like cake. I like everything you make. I like your fake tensor as size. Covered up in toughness soup. When I see your jelly roll, baby, I lose my self-control. Yeah. Yeah, okay. Let's actually assert on the ha ha ha. I did choir in high school. Went pretty far. And then I gave it all up. I'm teaching my kid how to sing. Well, not very successfully. She's only 3. But she can sing Twinkle Twinkle and ABCs. Where is my expected inline? I need this. Well, I don't remember anything when I was young, so, you know. By the way, what I'm doing here is I'm using our expect test mechanism. So what this does is it's like, okay, I want to check what the this string is equal to, and I'm too lazy to actually write it all out by hand. So I'm just going to you know, put in a blank string, and then if I run my test with this environment variable expect test equals 1, it'll automatically fill it in with whatever the value is. See, accepting new output. And I just reload my editor. There we go. Wonderful. And that looks good. Okay, send it in. What's lazy git? Does it like automatically generate commit messages? Oh no, Flake8 failed. Clang Tidy, why are you so slow? Hurry up. There's Jessie the Olin cowgirl. And Woody the man himself. Oh, adding in commit and push. Well, the problem with that, so I used to have tons of aliases and stuff like that. And then I'd like always be logging into random servers and they never have the aliases. And so like as I got older, I stopped like having as many aliases. Like I still have a few when they're like really, really useful and I'm willing to spend, you know, the 10 minutes like setting them up whenever I have a new environment. But I just don't go hog wild with this sort of thing anymore. I know some Bollywood songs. I know Om Shanti Om. I actually haven't seen very many Bollywood musicals. Darty disco, darty disco, darty disco, do 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 do. Do, 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 do. Okay, I think we're done. No, we're not done. So the problem is that I think there's a bunch of other these checks for is Dynamo compiling, and I suspect they are all susceptible to the same problem. So we need to go audit. I mean, if I'm feeling lazy, I'm not going to do this, but I feel like I should do this. Like, be a good citizen. Yeah, you see? This is the code, which is why the conversion works. Yeah, so I think we just don't need this logic at all. But let's check who added it. Oh, that's not gonna work. Did I review this one too? Oh, I got CC'd on this one. This is what I get for not actually reviewing stuff I'm CC'd to. Oh, do they add a test? Please they add a test. They did add a test. Okay, wonderful. Okay, so we're just gonna delete this code and then see if it still works. Did they add both lines? 1, 2. Yeah, they added both lines. Okay. Pete the old prospector and Woody the man himself. Oh, we probably can't get rid of this one though. So these are probably harmless. But what we probably can do is we can turn them on by default. Okay, I don't think this one is needed. Let's check this one out. Is that true? Uh-oh. Yeah, let's try. There was a boy, a very strange, enchanted boy. Over town and sea, the greatest thing you'll ever know is just to love and be loved in return. Yeah, not necessary. So let's just statically prove this one more time. No. When I have a variable and size 1 is greater than or equal to 0, in the jungle, a mighty If I have a plain number. Oh, you know what? This may. Oh, no, this is fine. Check long exact. THP variable check. Unpack it. Call var item. Push. Yeah, totally redundant. Oh no. And I want to think about the last one a little more carefully. So I believe that this is okay because I call int on it, on a regular tensor. And I got an int, and it's fine. But then C10 cement, you know what happens if I cast this to a C10 cement? So to find out what happens, I have to go look at the PyBind converter for this, which lives in PyBind, I think. Typecaster cement. And this says, hey, to load a PyObject into a C10 cement, check if it is a cement, then check if it is an index, and otherwise fail. Yeah, so we're just going to move this logic into there. So if these are true, then just go ahead and you don't. This is actually guaranteed to be true. So use an assert for that case. What is var? Var is circ. Oh, I gotta test if this is a THP variable. Oh no, unused variable 953. What are we doing? Make seed cement typecaster support FakeTensor scalar. We can't use index to do this conversion because that will trigger a guard. Get it dependent. Cement if the tensor is a fake tensor. But if we fetch item directly, put it in the scalar, we may still be able to make it work out. And let's just check those tests. And now we can get rid of is Dynamo compiling entirely. Hooray! I love deleting code. Yeah, that passed. All right, and we're all done. And it's 10 o'clock, so I am going to bed. Thanks everyone for joining.